Well, student, today we start the illustration of this chapter. It is a sole example that is given into the textbook. Okay, in the last lecture we had completed the theory about this chapter number 1. It is a electric charge in the field. Okay, today we are taking the first illustration. The question of this first illustration that is given into your textbook. We have just solved the example. We are not writing the question of the illustration. Okay, remember it, student. Okay, the first question of this one, there is a first illustration. How can you charge a metal sphere positively without touching it? How can you charge a metal sphere positively without touching it? It means what? Student, it is again charging by the induction method. It is called the charging by the induction method. In our textbook theory, we had studied the charging by induction, but that sphere becomes negatively charged. Now by using this illustration, the sphere becomes positively charged. Okay, for that one, student, first diagram, it is your A diagram. Into this A diagram, it is our metal sphere. It is to be held on this insulating stand. This is our insulating stand, this is our metal sphere. Initially this metal sphere, it is electrically neutral, no charge on it. No charge means what? Number of positive charges and number of negative charges, they are same. Okay, so now we are using a negatively charged rod. Now we are using the word negatively charged rod, and that negatively charged rod, it is brought it near to the sphere. This negative charges, it is attractively charges, positive charges, and due to the repulsive force of negative charges, the negative charge it is moved away from the rod. Once again, student, we are using the negative charge rod that is brought it near to the sphere. This negative charges, it is attractively charged positive, and negative charges, it is to be lying on the right hand side of the sphere due to the repulsive force. Number of positive charges and number of negative charges induced on the surface of the sphere, it is same, so that this sphere now attains equilibrium. This sphere now attains the equilibrium. Now no one charge can move towards the left side and no one charge can move towards the right hand side. Okay. So now the next diagram, it is a C diagram. Now this sphere through the conductor connected with the ground. It is called what? Earthing. It is called what? Earthing. We know very well what is the use of the earthing, student. Already also we studied. Earthing is what? It is conduct the electron from the body to the ground. It is conduct the electron from the body to the ground. This all the electrons, it is conducted by the ground. That is why it is called the grounding or earthing. So now this all the electron, it is conducted by the ground. These all the electrons move through this conductor to the ground. Now only which charges are remain into the D diagram? Only positive charges. Only positive charges. Now remove the rod into the E diagram. Then this all the positive charges, they are redistributed on the surface of the sphere, so that this sphere becomes which charge? Positively charged. Okay, initially this sphere, it was electrically neutral. Now finally this sphere becomes a which charge? Positively charged. The sphere becomes positively charged by using the which rod? Negatively charged rod. By using the which rod? Negatively charged rod. So again, this is called the word induction. It is a charging by the word induction without making any physical contact. Okay. Student, there is our next illustration. The question of this next illustration, it is like this. The next illustration, it is for the water, in a cup of water. Okay. The next illustration, sorry, it is student my mistake, not it is for the cup of water. Into next illustration, if 10⁹ electrons move out of a body to the another body in every second, 10⁹ electrons are moved from the one body to the another body in 1 second. Like we are removing the 10⁹ electrons in 1 second. Okay, how much time is required to get a total charge of 1 coulomb on the other body? How much time is required to get a 1 coulomb charge on the other body? Like calculate the time for the 1 coulomb charge. Student, in every 1 second, we have removed how many charges? 10⁹ charges. So that is to be explained into this one. This example can be solved by using the equation of quantization. Q is equal to Ne. Okay. So n is equal to 10⁹ electrons are removed from the body in 1 second. When we remove the charge, when we remove the electrons, then the body is going to what electrically, the body is going to what charge. So now calculate the charge in 1 second. Produce charge in 1 second, that is Q is to N E, where N is equal to 10 to 9. E is equal to 1.6 into 10 to minus 19 plus 9 minus 19 10 to 10 remain. Therefore, the charge produced in 1 second 1.6 into 10 to minus 10 coulomb. This much amount of the charge is produced in 1 second. It is 1.6 into 10 to minus 10 coulomb. So we require the time to produce the 1 coulomb charge. For this much charge, time is 1 second. For this much charge, time is 1 second. We write down this. For a charge 1.6 into 10 to minus 10 coulomb, the required time is 1 second. For a 1 coulomb charge, time is dash. Student, now cross multiply 1 into 1, it is 1 divided by 1.6 into 10 to minus 10 coulomb. Therefore, time t is equal to 1 upon 1.6 into 10 to minus 10. 1 by 1.6, 0.625. 10 to minus 10, write down in numerator, it is plus 10. Now displace the decimal, so that time is 6.25 into 10 to 9 second. Student, it is a required time to produce a 1 coulomb charge. It is a 6.25 into 10 to 9 second. So this second is very large second. Convert this answer into the year. We know very well 1 year is equal to 365 days, 24 hours and 3600 seconds. Okay? So now write down, convert into year. 1 year is equal to 365 days. Convert the days into hour, 24 hour. Convert the hour into second, 3600 seconds. So that this second convert into year. So this whole equation, this whole value divided by now 365 multiply 24 and multiply 3600. So when this value divided by this value, then answer will be converted into year. That answer will be coming 198 year. So that student, we can say that to produce a 1 coulomb charge in a given body, required time is 198 year. 198 year. When the charge 10 to 9 electrons are removed from the body in every second. Okay, very simple example. Okay. Now student, there is the next illustration number 3. It is about the water. Now the next illustration. The question of this illustration, it is like this. How much positive and negative charge is there in a cup of water? How much positive and negative charges is there in a cup of water? Cup of water, mass of the cup of water, you remember it is 250 gram. Mass of cup of water, it is 250 gram. Student, in a cup of water, mass is 250 gram. Molecular mass of the water is 18 gram. Molecular mass of the water is what, 18 gram. Okay. Next is, student, we require the actually total number of positive and negative charges. Again, the which equation can be used? Q is equal to N. Simple. First of all, calculate the number of molecules, and each molecules contains how much positive positive protons and electrons. Through that way, we can calculate the total positive and negative charges in a cup of water. The first thing is calculate number of molecules. Second thing is calculate each molecule contains how many electron and proton. These two things, it is a important things to solve this example. Okay, again, mass of cup of water, it is at 250 gram. Molecular mass of the water is 18 gram. Calculate number of molecules in a 250 gram water. So the student, mass of water is equal to number of molecules. 18 gram mass of water, molecule 6.02 into 10 to 23, it is your Avogadro number. In a 250 gram, number of molecule is dash. So the number of molecule in a cup of water is equal to, cross multiply, 250 multiply 6.02 into 10 to 23 divided by 18. Okay? By calculating them, your answer will be coming 8.36 into 10 to 24 molecules. So these are the number of molecules in a cup of water. If one thing it is completed, now calculate the charge in each molecule. So it is a H2O. Water means H2O. It contains 2 hydrogen, 1 oxygen. 2 hydrogen, 1 oxygen. So the student, each molecule of water H2O contains 2 hydrogen and 8 oxygen. 2 hydrogen and 1 oxygen. Hydrogen has 2 proton electron and oxygen has 8 electron proton. So that total charge on the H2O in each molecule, it is a 10 electron as well as proton. So remember it, total charge of the water of the each molecule, it is a 10. It contains 10 electrons and it contains 10 protons. Their value always same. Now, each molecule has a 10 electron proton. For this much molecule, the number of electron proton is dash. Multiply them so that total number of electrons and protons present in a cup of water, that is given by n dash is equal to, it is a n into 10, n into 10, where n is equal to 8.36 into 10 raised to 24 multiply 10, so that n dash is equal to 8.36 into 10 raised to 25, 24 plus 1, 25. So this is the number of electrons and number of protons. So now which equation can be used? Q is equal to NE. Q is equal to NE. So the number of total negative and positive charges has magnitude. Q is equal to n dash E, where n dash is equal to 8.36 into 10 raised to 25. Charge on electron is equal to 1.6 into 10 raised to minus 19. By multiplying them, your answer will be 1.34 into 10 raised to 7 coulomb. See, this much amount of the charge, it is contained by the cup of water. So once again, the cup of water means 250 gram. Cup of water means it is at 250 gram. Okay, now this illustration is completed. Now students, we are moving on the next illustration, that is your illustration number 4. Now the question of this illustration number 4, it is like this, and it is related to the Coulomb's law. It is related to the what? Coulomb's law. So we know very well Coulomb's law is which one? Coulomb's statement of the Coulomb's law, it is which one, student? Electrical force acting between the two stationary point charges is directly proportional to the product of their charges and inversely proportional square of the distance between them. So now the illustration number 4, it is related to the Coulomb's law. It is related to the Coulomb's law. Okay? Student, in this example, we are comparing the electrical force and gravitational force. And another things, in this example, also we find the acceleration of the electron and acceleration of the proton. These things we require in this example. Once again, we are comparing the electrical force and gravitational force, and we found the acceleration of the electron and acceleration of the proton. Okay? So the question of this one, it is like this. Coulomb's law for electrostatic force between 2 point charges and the Newton's law for the gravitational force between two stationary point masses both have inverse square independence of the distance between the charges and masses. Where the first question A, compare the strength of these two forces by determining the ratio of their magnitude for an electron and proton, and second case for the two proton. Compare the or determine the ratio of electrical force to the gravitational force for an electron and proton and between the two protons. Next question B, estimate the acceleration of the electron and proton due to the electrical force of their mutual interaction when they are 1 angstrom apart. Mass of proton is equal to 1.67 into 10 raised to minus 27 kilogram, and mass of electron is equal to 9.1 into 10 raised to minus 31 kilogram is given. Student, in this one, total actually there are two questions. First question, determine the ratio of the electrical force to the gravitational force between the electron and proton and between the two protons. And your second question, calculate the acceleration of the electron and proton. Okay? Student, now electrical force acting between the electron and proton at a distance r. So we know very well charge on electron, charge on proton, they are same. Magnitude of their charges are the what same. Therefore, the electrical force acting between them is given by K E square by R square. K E square by R square. And the next one, gravitational force acting between them, between the electron and proton. Now what happened? That Fg is equal to capital G, mass of electron into mass of proton by R square. Now what changes takes place? First case, it is for the electron and proton. And the next case will be between the two protons. The same equations can be used. Determine the ratio of them. Now divide Fe by the Fg. Fe by Fg, where Fe is equal to Ke square by R square. Fg is in G, Me, Mp by R square cancel. So the remaining steps are K square by G, Me into Mp. This step is remaining. Substitute their values. Value of K is equal to 9 into 10 to 9. Charge on electron is equal to 1.6 into 10 to minus 19 whole square. Capital G 6.67 10 to minus 11. Mass of electron 9.1 10 to minus 31. Mass of proton 1.67 into 10 to minus 27. By calculating them, your answer will become in 0.227 10 to 40. Now displace the decimal towards the right side, so that your answer is 2.27 10 to 39. 2.27 10 to 39. Okay. Now student, there is a same equation can be used. Same equation can be used between the two protons. So now what changes takes place? Any replaced by mass of proton. Only this any replaced by the word mass of proton. So that this equation, now rewrite it again. Similarly, the ratio of magnitude of electric force to the gravitational force between the two protons at a distance r can be given by Fe by Fg as it is. Only this change takes place, Ne replaced by Np, so that K square by G, Np into Np. Again student, K is equal to 9 into 10 to 9. E is equal to 1.6 10 to minus 19 whole square. Capital G is equal to 6.67 10 to minus 11. Mass of proton is 2 times, so you multiply them, so that make it square. 1.67 into 10 to minus 27 whole square. By calculating them, your answer will be coming 1.238 into 10 to 36. Okay. Student, here the answer is coming 10 to 39. Here the answer is coming in the order of 10 to 36. So that we can say that this electrical force is much stronger than that of the gravitational force. Much stronger than that of the gravitational force. The ratio of the two forces shows that the electrical forces are much stronger than that of the gravitational force. Okay. So now there is a big question. Calculate the acceleration of the electron and acceleration of the proton. Both are separated by distance of 1 angstrom. 1 angstrom is 10 to minus 10 meter. Okay. Now the electrical force acting between the electron and proton. Acting between the electron and proton. It is given by Fe is equal to K square by R square. Well, electrical force between the electron and proton, it is same, and between the proton is also what same, but acceleration is different because their masses are different. So that F is equal to K square by R square, equation number 1. From the Newton's second law, we know very well F is equal to Ma. From equation number 1 and 2, Ma is equal to K square by R square. Now please make a subject of a mass randomly division. Therefore K square by mr square. It is the equation number 3. Through this equation we can calculate acceleration of the electron, and through the same equation we can calculate the acceleration of the proton. What changes takes place? First m replaced by mass of electron, and second time replaced by mass of proton. Simple. Okay. Therefore acceleration of the electron A is equal to K square by mass of electron into R square, where K is equal to 9 into 10 to 9, E is equal to 1.6 10 to minus 19 whole square. Mass of electron is equal to 9.1 10 to minus 31, and distance r is equal to 10 to minus 10 whole square. So that their answer will be coming 2.53 into 10 to 22 meter per second square. Okay, now this is our acceleration of the electron. So now calculate the acceleration of the proton. Simple changes takes place. This mass replaced by mass of proton. Same equation can be used. Again, only what changes takes place? Mass of proton. Remaining all the things are as it is. Where K is 9 into 10 to 9. E is 1.6 10 to minus 19. R is 10 to minus 10. Mass of proton is 1.67 10 to minus 27. By calculating them, your answer will be coming 1.4 into 10 to 18 meter per second square. 1.4 into 10 to 18 meter per second square. Student, observe these two values. Acceleration of the electron is 10 to 22. Acceleration of proton is 10 to 18. This acceleration is also much larger than that of the gravitational acceleration. Than that of the what? Gravitational acceleration. Okay, student?